We are going to deal a little bit more with matrices today and their inverses. So we talked last time about how an identity has three purposes. The identity is the number or the element that doesn't do anything. For addition, the identity is 0, and for multiplication, the identity is 1. For functions, the identity is y equals x. They don't perform anything. What you put in, you get out. Okay, they don't change anything. Also, the identity is what you get when you combine any element with its inverse. So if I had 3 and I combined it with its additive inverse, -3, I get 0. Okay? And then if I had 5 and I combined it with its multiplicative inverse, which is 1/5, I get 1, which is the multiplicative identity. Okay? And then the identity is its own inverse. That's the other option. So how do we find the identity? What if we don't know what it is? How do I find the identity? You could find the inverse and combine the original element with the inverse, and you could create the identity. All right? What if I knew the identity, but I didn't know the inverse? How would I find the inverse? So if I had some number and I combined it with something else, and for multiplication the identity is 1, how would I find that? Well, let's have an example. If I had 5 times x equals 1, I would divide by 5, and I would get x is 1/5. So over here, I could divide, and x is 1 over a. So a's inverse is 1 over itself. That's the multiplicative rule. Okay, let's look at addition. If I had a plus some number equals 0, how would I find what the inverse is? I would subtract a, and I get x is equal to -a, which means a and -a are inverses. So how do I find the inverse of a matrix? Well, first, we need to remember that matrix multiplication is not commutative. And we could talk about the identity matrix for addition. What would the identity matrix for addition be? It would just be the exact additive opposite of all of the original. So whatever is in your matrix, it would be the same size, but you change all the signs. Okay? We never do that with matrices. We never talk about additive inverse. So when I say matrix inverse, I always mean multiplication. Okay, but we need to review a couple things about multiplication. How do you know if you can multiply two matrices together? So if I had a 3 by 4 and I multiplied that by a 2 by 3, can I multiply those? No, why not? The number of rows, the number of columns in the first matrix has to be equal to the number of rows in the other matrix, because when you build that lattice, you're going to multiply individual elements and then add them together. And if the list of elements are different sizes, then there's nothing you can do. All right? What about this? A 4 by 2, and we're going to multiply that by a 2 by 3. Is that doable? Yes, because these match. How big is the answer? 4 by 3, which is kind of weird. We took a 4 by 2 and a 2 by 3, we multiply them, and we end up with a 4 by 3, which is not the same as either one of those. But that's how multiplication works. There's another important thing. A times B is equal or not equal to B times A. That is not true except if they're inverses or if B is the identity in some cases. Right? So if B was I3, then it would work as long as A was square. Right? If I had a 3 by 3 times I3, that's going to be exactly the same as I3 times a 3 by 3. But what if A is a 4 by 3? Then this doesn't exist. So in general, AB and BA are not the same, unless they're inverses. But what does that tell you about inverses if AB and BA both exist? They have to be square, right? So if A and B is equal to B and A, then B is A inverse. And the way we write A inverse is this, A to the negative 1. Which tells us, excuse me, the only way to find the only matrices that have inverses are square matrices. And even then, it's not a guarantee. There are some square matrices that are not invertible. Just like there are some functions that are not invertible. You can't invert a parabola and create a function because it fails the horizontal line test, so when you invert it, it will fail the vertical line test. So let's do a little bit of algebra. I want to find the inverse of matrix A. So A times what is equal to the identity, and we'll just do this as a 2 by 2, I2. So if I know what A is, can I find the inverse where I can multiply A by something and get I2? So let's pick an A. 1, 2, oh, hold on, I got to do this right or it's going to be pretty nasty. Let's take this. This matrix times some unknown matrix is equal to, what does I2 look like? 1, 0, 0, 1. I think this is going to work. How do we multiply two matrices together? So I'm going to put 1, 2, 1, 3 here. And I'm going to multiply these together. And I don't know what's in there. So let's just call it A, B, C, and D. And we'll take it. So this one right here would be what? 1A plus 2C. So A plus 2C. Okay, the next one is going to be B plus 2D. And the next one would be A plus 3C. And the next one would be B plus 3D. Okay. Now what? So I know that A plus 2C is equal to 1 because this box here has to be 1. And then this box has to be 0. So B plus 2D is 0. Okay, what else? A plus 3C is equal to 0. And B plus 3D is equal to 1. Yep, we could, but how many variables do we have? 4. And in order to have in order to solve a 4-variable equation, I have to have, yeah, that's right. In order to solve a 4-variable system, I have to have how many equations? 4. Okay, so I'm going to put this in my matrix. How big is my matrix? 4 by 5, right? There's an A column, a B column, a C column, a D column, and an answer column. So I'm going to go into second matrix, go over to edit. Oops, not determinant. That's not what I want. Edit. And this is a 4x5. Okay, what goes in my first row? Good. Not 1020. 10201. 10201. Okay. And the next row? 0102. And you could do this through substitution if you wanted. Oh, and 0. But let's just use the matrix. Okay. And then 1, 0, 3, 0, 0. That takes care of equation 3. And 0, 1, 0, 3. Oh, wait. No, that's right. 3, and then 1. Okay. So exit out. Second matrix. We want to do the RREF of matrix A. And don't worry, we'll never do this again. This is a really long way to do it. But I end up with A equals 3, B equals -2, C equals -1, and D equals 1. So what does that tell me? What was the goal here? I was trying to figure out what the inverse of matrix A looked like. What does it look like? 3, -2, -1, and 1. So this is something Morgan picked up on yesterday, and she sees it again today. Do you see a relationship between A and A inverse? So these swapped, right? And then the other two changed signs. Yes, with one exception. Okay, that is the first part of the rule for finding the inverse of a 2x2 matrix. But there's something else in play. Okay, every matrix has what is called a determinant, and the determinant is basically a scaling factor. Okay, so I've talked a lot about digital photographs. So if you start with a certain size of a digital photograph and you multiply that by a matrix which will perform some operation, whether it's a rotation, reflection, manipulating the colors or eliminating certain colors, as long as the size, well, that's not true. As long as the weight of the matrix doesn't change, then the original transformation matrix had what is called a determinant of 1. And I don't know how well you're going to understand this, but this matrix has, it's basically a weight. And that matrix needs to weigh just as much at the beginning as it does at the end, or something has been changed. Okay, so the weight of a matrix is, the weight of an inverse matrix is the reciprocal of the weight of the original matrix. Okay, and this matrix I showed you had a weight of 1. It's called the determinant. It had a determinant of 1. So its inverse would have a determinant of 1. So that's why it ended up being such nice numbers. But if the original matrix had a weight of 5, then the inverse matrix would have a weight of 1/5. So when you multiply the 5 and the 1/5 together, you end up with 1. Okay? So the rule for finding a finding the inverse of a 2 by 2 is you switch A and D, you make B and C negative, and then you have to undo the weight. But this one had a weight of 1. And the weight of a matrix is found by doing AD minus BC. That will tell you how much a matrix weighs. So in this first matrix, 1 times 3 is 3, minus 2 times 1 is 2. The original matrix had a weight of 1, so the inverse will also have a weight of 1. Okay, so let's find another inverse. Oh, while we're here, let's just verify. How do I know that I'm right? Right, when I multiply these two together, I should get I2. So let's check. 1 times 3 is 3. 2 times -1 is -2. I get a 1. 1 times -2 is -2. Plus 2 is 0. 3 minus 3 is 0. -2 plus 3 is 1. So I'm right. Okay, but we're never going to do this again. Okay, it just takes too long. So if I had 4, 5, and 2, and 9, what would, so if this is A, what would A inverse look like? I'm going to switch the 5 and the 4. So 5 here and 4 there. And then I make the 2 and the 9 negative. So -2 and -9, but I have to worry about its weight. How much does this matrix weigh? Well, the weight is always A, wow, that was nice, AD minus BC. So that would be 20 minus 18. This matrix weighs 2. So I have to undo that 2 in the other matrix. Or times by 1/2. Yep. I'm going to divide everything in there by 2. So 5 over 2 minus 9 over 2 minus 1, and then a 2. Fractions. Yeah, fractions are much better. Does that make sense? You swap A and D, and then you make B and C negative, and then you have to invert the determinant, the weight. Okay, and the determinant is a really important thing, but this is the only reason we're ever going to use it. Okay. All right, let's do. Oh, yeah, we'll get to that in a second. And then let's say. Let's say 1 and 5/3. If this is A, what does A inverse look like? So we would switch the 2 and the 1, and then we would make this negative, and then we would make this negative, and then we need to calculate the weight. 1 times 2 is 2 minus 5/3 times 1 is 5/3. 2 minus 5/3. 1/3. 2 is really just 6 over 3. So 6 over 3 minus 5 over 3 is 1/3. So the weight of A is 1/3, which means the weight of the inverse would be 3. So I need to triple everything on the inside. So A inverse is really 6, -5, -3, and 3. Yes, because my weight was 2, so I times everything by 1/2 because that's the reciprocal. Okay? Now, guess what? I don't ever want to do that again. Okay? Especially on a 3 by 3. In a 3 by 3, I would need to put A, B, C, D, E, F, H, I, J. And then I would need to perform that multiplication, and then I would get a matrix that was a 3 by 3, and each one would have 3 variables in it, but A, B, C, D, E, F, H, I, J, that's 9 variables. I would need to set up a 9 by 10 matrix and put in all the coefficients, and then I would need to do RREF, and I would get A through J, and then I would plug those back in and look for a pattern, and then you realize there isn't one that makes any sense. So the only way to find the inverse of a 3 by 3 is to do that system, a 9 by 10 system, or we're just going to ask the calculator, hey, what's the inverse? Okay? So let's do this. 5, 2, 3, and 6. First of all, what's the weight of this matrix? 15 minus 12 is 3. So I would end up multiplying the answer by 1/3. So I will expect the inverse matrix to have a bunch of divide by 3's in it. So go into your matrix. Okay. And we're going to do a 2 by 2. Okay. So that's my matrix. All right. Exit out. And then do second matrix and A. What do I want to do with A? I want the inverse. Where's the inverse button? Yep, it's the power -1, which is, right next to the matrix button. Imagine that. Second, or not second, sorry. It's just raised to the -1. And I will get that. Now, that's messy. If you push math fraction, it will clean it up for you. Is that what I would have expected? Well, I switch the 5 and the 3, and I negate the 2 and the 6, and then what do I need to do? Multiply everything by 1/3. So 3 times 1/3 is 1, -2 times 1/3 is 2/3, -6 times 1/3 is -2, and 5 over 3 is the final piece. Okay? Now we can do the same thing with the 3 by 3. If that's my matrix, go over to Edit, and this is a 3 by 3, and then I just want to do A inverse. Oh, oops. That's a problem. Here we go. So 3 by 3, 1, 0, 2, 0, 1, -2, 0, 1, -3. All right, now I'm going to say take the inverse of A. Wow, I guessed really well. Usually there are some terrible fractions inside there because you have to, finding the weight of a 3 by 3 is much more complicated than finding the weight of a 2 by 2. You essentially have to find the weight of each 2 by 2 and then combine them. So you take those 4 weights and then you combine them into one, which, yeah, we're not going to do that. So that's the inverse. Part of your assignment today is find the inverse. Type it in your calculator, click A to -1, and you're done. All right? Now, what does the inverse do for us? Well, lots of things, but let's look at a particular, or let's look at another way to solve a system. And you're going to look at this and say, wait a minute, I already know how to find the answer. But the idea here is to learn more about matrices. So let's take a linear system. For instance, let's take 2x minus 3y is equal to 12. And x plus y is equal to 1. Now normally, we turn this into a 2 by 3 and we do RREF. But today your RREF button is broken. I disabled everybody's. Well, the first part you don't need it. The first part you're just using the inverse button. So I have gone through and disabled everybody's RREF button. What are we going to do? So, let me show you another way to represent this. RREF gets rid of all of the variables. Okay? So I am going to make a matrix that is the coefficient matrix, the variable matrix, and the answer matrix. So the coefficient matrix is 2, -3, 1, and 1. Okay? And then I'm going to multiply that by the variable matrix, x, y. So this is a 2 by 2 multiplied by a 2 by 1. So the answer should be a 2 by 1. These match. So the answer should look like this, and the answer is 12, 1. Oh, I put that in the wrong place. Sorry. That is another way to represent the system using matrices. Okay? So, simplified down, this is matrix A times my variable matrix X equals my answer matrix B. Okay? So these variables don't represent numbers, they represent matrices. So, if I had A times X equals B, how do I solve for X? Divide by A. How do you divide matrices? It doesn't exist. Right. Instead of dividing, because there is no such thing as dividing matrices, I want to turn this into the identity, because the identity times X will just be X. So what I do is I multiply both by the inverse. And I get A inverse times A is I2 times X equals A inverse times B. And what is I2 times X? X. And this is a 2 by 2 times a 2 by 1, which is possible. And my answer will be a 2 by 1. So that will give me my answer. So X, not X over Y, sorry. X, Y will equal my first answer and my second answer. Okay, so here's what we're going to do. I'm not going to make you calculate A inverse, although on a 2 by 2 it's really easy, right? This would be 2 plus 5, or plus 3 is 5, so I'd have to multiply everything by 1/5. Okay, but I'm not going to make you do that. Let's go into matrix. We go into edit, 2 by 2, and my matrix is 2, -3, 1, and 1. Yes, it was. Okay, so I find the inverse, and I do math fraction. So I get A inverse is equal to 1/5, 8/5, -1/5, and 2/5. Okay. Let me move these over. So what I'm going to do is I'm going to bring this matrix over here. What happens when I multiply these two together? They cancel. They turn into I2. So I'm left with, that goes away, I'm left with xy is equal to this matrix, 1/5, 8/5, -1/5, and 2/5. And I'm going to multiply that by this matrix, 12 and 1. And whatever I get from that should be my answers. So the answer is just going to be a 2 by 1. What is 1/5 times 12? What was it? Oh, 3/5. Sorry. So 1 and 3/5. No, we put it on both sides. So we put it here and we put it here. That's how you move a to the other side, because we can't divide. So we just use the inverse. So 1/5 times 12 plus 3/5 times 1. So 1/5 times 12 plus 3/5 times 1 is 3. Okay. -1/5 times 12 plus 2/5 times 1. So -1/5 times 12 plus 2/5 times 1, and we get -2. What does that tell me? X is 3 and y is 2. -2. Okay, so you don't need to find the inverse yourself. You can ask your calculator to do it, but then you need to multiply the inverse by the answer matrix to create the answers. So let's do one that's bigger. So let's do this one. So 1, -1, this is 68. 1, 0, x, y, z. And then 1x plus 1y plus 1z equals 2. And then -x plus 2y plus minus 3z equals 1. Now, how are you going to tell if a matrix has no solution or infinite solutions? You end up with a matrix that's not invertible. If you try to take a matrix and invert it and you get error, that means, it means a lot of things that we're not going to get into, but essentially it tells you that the system has no solutions or one solution. You don't. I mean, there are other ways to find out, but the inverse won't tell you that. So hopefully that doesn't happen. So we need to set up the algebra. We need to set it up into ax equals b. So a is going to be 1, -1, 1, 1, 1, 1, and -1, 2, -3. What is my variable matrix? X, Y, Z. And my answer matrix is 0, 2, 1. Okay. So I need to find A inverse. Go to my calculator, second matrix, edit a 3 by 3. And I get 1, -1, 1, 1, 1, 1, -1, 2, -3. And then I go out and I do A inverse. Oh, how fun is that? So 5/4, 1/4, 1/2, negative 1/2, 1/2, 0, negative 3/4, 1/4, and negative 1/2. Okay, and then I need to multiply this by that, and the answer is I3, and I3 times x is just x, so essentially that cancels. And then I need to multiply this. Does it matter what side I multiply it on? So if I put it on the left, I get 3 by 3 times 3 by 1. But if I put it on the right, 3 by 1 times 3 by 3, that doesn't exist. So it has to be on the left. I put it on the left over here, and I put it on the left over here. So now all I have to do is multiply this and this together, and then I'm done. Yes. As long as it is truly the inverse, then it will always cancel into I2 or I3, whatever. Yeah. So I need to multiply this by, what was the answer matrix? 0, 2, and 1. So this is going to be a 3 by 1 matrix. So that's 0, 1/2, 1/2 gives me 1. 0, 1, 0, that will give me a 1. 0, 1/2, negative 1/2 is 0. So the solution to the matrix is x equals 1, y equals 1, and z equals 0. And once again, we already know how to find that, but I disabled your RREF buttons. So, and remember, the rule here is if I take ax equals b, and I want to solve for b, well, if I want to solve for x, I take the a inverse of both sides, and this turns into I whatever, I sub n, depending on how big your matrix is, times x is equal to a inverse times b, but I sub n times x is just x. So the answer to any system is always the inverse of the coefficients multiplied by the answer matrix. And that's all that RREF does. Essentially, it finds the inverse of matrix A, and then it multiplies that by the answers, and that's where it comes from. Because when you do RREF, don't you get you end up with I sub n, and then the answers, right? This part of the matrix is always 1, 0, 0, 1, and then those are the answers, which is essentially this and that. So I guess technically your RREF button's not disabled. You just have to do it the long way. Okay? Yes? Question? Oh, okay. All right. Good luck.